Welcome to High Yielding Topics. We are in geography और अभी देखेंगे insolation. We'll begin our discussion with definition and then its significance. Then we'll understand the types of electromagnetic radiation और एक बहुत important relation है between the energy and the wavelength of a wave. उसको समझने की कोशिश करेंगे. Then we'll look at the range of insolation. And then we'll try to understand the mechanism of heating the Earth's atmosphere. Thereafter, we'll look at the role of greenhouse gases present in the atmosphere. And then we'll look at the variation in the insolation. And then we'll look at previous year questions to test our understanding. All right, so let's begin. So what is insolation? Insolation, as the name suggests, is incoming solar radiation. तो ये है क्या? धरती पे जो सूरज की किरणें आती हैं उनको हमने इंसुलेशन कहा. इसकी क्या आवश्यकता है, क्या सिग्निफिकेंस है हमारे लिए? With this we'll understand how does the earth get heated, and upon being heated, how does the earth heat its atmosphere? यानी अर्थ का जो एटमॉस्फेयर है डायरेक्टली हीट नहीं होता है from the incoming solar radiation. It gets heated by the earth. We'll understand that. सबसे पहले, to begin our discussion, let's understand the electromagnetic radiation. Beginning on the rightmost side, we have the gamma rays, followed by X-rays, then ultraviolet rays, then visible light, then infrared, then microwaves, and then at last we have radio waves. So gamma on the rightmost side represents in the electromagnetic radiation spectrum represents that it has the highest energy of the electromagnetic waves. Okay? And as we move to the left, the energy decreases. So this order must be kept in mind. So let me repeat it for you once again. Gamma rays, followed by X-rays, followed by ultraviolet rays, followed by visible rays, followed by infrared rays, followed by microwaves, and followed by the radio waves. All right. One more thing which is really important here is to understand the wavelength. All right. So what is wavelength? Wavelength is the minimum distance after which a wave repeats itself is wavelength. Okay? Meaning that this line that I have drawn in blue is the minimum distance after which clearly is the minimum distance which after this wave will repeat itself. So this is lambda. Now, let's get back to the spectrum again. If I ask you the wavelength of gamma rays, what can you say? Versus say that of visible light, versus say that of radio waves. It is increasing. It is increasing. So what we can see, as we are moving away, as we are moving towards the waves with lesser energy, the wavelength is increasing. And this is what I want us to understand. That energy, I don't know why the pen is not working here. Energy is inversely proportional to the wavelength. Yani, higher the energy, smaller will be the wavelength. Shorter will be the wave. Okay? Ashkan. Now, why did we study electromagnetic radiation? Because the insolation which the Earth receives ranges between ultraviolet to near visible. Let's understand this better. Ultraviolet constitutes a very small portion, and it is the ultraviolet, the exposure to which causes sunburn. Okay? Now we have visible light. Visible light is the major component. And it is visible light that we see as the daylight. All right. So visible light is a major component. And then we have near infrared. And mind you, it is not infrared. It is this which is felt as the warmth. All right. Now having understood the range of insolation, let's try to understand the mechanism of heating the Earth's atmosphere via conduction, convection, radiation, and advection. Conduction is when the immediate earth, the earth surface, and the immediate layer of earth, immediate layer of air, immediate layer of earth being in contact gets heated. Then the heat thus transferred is through by conduction. देख रहे हैं आप यहाँ. The immediate layer of air gets heated. All right. Let's understand convection. Convection. So hot air rises and cool air sinks. As the hot air rises, it creates, let me change the color. Let me take red. As the hot air rises, it creates a current, vertical current. This vertical current due to convection is called convection current. All right, convection current. This convection current is so strong that at places such as equator, it ends up increasing the height of the troposphere. I'm sure we are aware that the height of the troposphere at the equator is about 16 to 18 kilometers, and at the poles, it is 8 to 10 kilometers with an average of 13 kilometers. All right. So what is the reason for the higher height of the troposphere? It is majorly because of the strong convectional current which is generated at the equator because of the equator lies in direct angle with the sun. Now let's understand radiation. Earth receives solar radiation. Now, one more thing that we need to understand, that Earth receives just 2 units of solar energy, which out of the 1 billion units of the energy which the sun produces, just the 2 units. So can we say that the energy which is coming from the sun is strong? Is it strong? Of course it is strong. And what have we learned? That stronger energy will have a shorter wavelength. All right. So the energy, the radiation, the wave which is carrying the radiation from the sun will be of short wavelength, right? Will be of short wavelength. And since it is having higher energy, the Earth's atmosphere is nearly transparent to it. The Earth's atmosphere is nearly transparent to it because of higher energy. So it directly reaches the Earth's surface and it heats the Earth's surface. Upon being heated, now it is the Earth which will start radiating this heat back in the atmosphere. But now tell me, what kind of radiation would the Earth emit? Is it going to be as strong as the sun, as strong as is from the sun, or is it going to be weaker than that of the sun? Because it's going to be weaker, because the Earth would not radiate all the radiation that it has absorbed, which it has absorbed from the sun, right? So it's going to be weaker. So if it is weaker, then it must be of long wavelength. So it must be long wavelength, right? So we'll call it long wave. And that coming from the sun is short wave, right? So what Earth radiates is long wave, and generally it falls under the infrared. All right. So this infrared radiation has lesser energy, right? Now this is being radiated back towards the sun. Now this has lesser energy, and it is here that when it is radiated back, as it has lesser energy, this will be trapped by greenhouse gases such as carbon dioxide, such as water vapor, such as methane. It will be trapped because of the lesser energy. And upon them being trapped, they will increase the temperature of the Earth's atmosphere. And this is not at all completely hostile to us. In fact, this is which makes the Earth habitable, hospitable for human life. What is problematic is their presence in excess. The excess presence of it causes global warming. The excess presence of the greenhouse gases causes global warming. So with this, we do understand that insulation will vary. That is going to be lower at the equator. Why? Let me just change the color so that it will be more visible. Because of the shorter distance which the rays will have to travel, and it will be concentrated in a small area. So it's going to be stronger. It's going to be more during the summer in comparison to winter. It's going to be more in the afternoon in comparison to morning or evening. And as we talk about the equator, so it is really obvious that equator receives far much more insulation than what is received at the poles. But the question is how much? How much? So it is nearly to the tune of 2 to 2.5 times. 2 to the 2 to 2.5 times. Let's understand one more thing. The heat budget. Heat budget. Heat budget. Of all the rays which the sun receives, of all the rays, of all the insulation that the earth receives, nearly 30% of it is reflected back. Nearly 30%. 30%. And 19% is absorbed by the earth's atmosphere. And only 51% reaches the earth's surface. So this reflectivity by the earth's surface is referred to as albedo. Albedo. So let's begin with the previous year question papers to test our understanding. So this is from 2024, and the statement says the thickness of troposphere at the equator is much greater as compared to the poles. Is it? Yes, it is. We have seen that the thickness is around 16 to 18 kilometers at the equator and 8 to 10 kilometers at the pole. So that's the case we have already discussed. At the equator, heat is transported to the greater height by strong convection currents. We have already seen. So, does the statement 2 explain the statement 1? Is very obviously statement 2 is explaining statement 1, and thus option A is the correct option. All right, let's look at the statement, the second question. The second question is from the year 2023. It's about insolation versus infrared rays. So with reference to Earth's atmosphere, which one of the following statements is correct? The total amount of insolation received at the equator is roughly about 10 times than that received at the poles. No. It is, as we just discussed, was about 2 to 2.5 times, right? Infrared rays constitute roughly 2/3 of insolation. Is again wrong. Why? Because 2/3, it means nearly 67%. Nearly 67% means the majority, but we have seen that in insolation, it is the visible rays which constitutes the majority. So again, option B is incorrect. Let's look at option C. Infrared rays are largely absorbed by water vapor that is concentrated in the lower atmosphere. Water vapor, greenhouse gas, infrared waves, lower in energy, so will be trapped. So is correct. Let's look at the option D as well. Infrared waves are part of the visible spectrum. No, we have seen, and that's the reason I stress upon us learning the electromagnetic spectrum. So infrared waves are not part; they are apart from there's a separate category of infrared rays. So option C is correct. Let's look at another question. This is question number 3. There is a little bit of typo. Statement A, statement B. Option A, option B, option C, and option D. Let's look at the statements. The atmosphere is heated more by incoming solar radiation than by terrestrial radiation. Absolutely wrong. Atmosphere is heated heated more by the terrestrial radiation and not by the incoming solar radiation, because incoming solar radiation, higher energy, will pierce through the atmosphere. Atmosphere will be nearly transparent. And as we record this lecture, as per the latest pattern, in these statement one and in these statements containing in these questions containing two statements, if the first statement is incorrect, then there is only one statement. There is only one option which is correct, and which is the option D, which says the statement one is incorrect, and then statement two, according to this arrangement, must be correct. And let's look at the statement two, which says that carbon dioxide and other greenhouse gases in the atmosphere are good absorbers of long-wave radiation. We have just understood that long-wave radiations, lesser energy, will not be able to make it through, but will be observed by the greenhouse gases. So thus is correct. So let's just quickly repeat. We began our discussion with what our insolation is. What insolation is? Nothing but incoming solar radiation. We understood the electromagnetic spectrum with gamma rays, followed by X-rays, then ultraviolet, then visible light, then infrared, microwaves, then radio waves. We saw that insolation lies between ultraviolet, visible, and near infrared, not infrared, and visible light forming the major chunk of it. Then we understood convection and radiation. Convection at equator is so strong that it increases the height of the troposphere considerably, and radiation is what heats the atmosphere. And upon being radiated, they are with lesser energy. They are being trapped by greenhouse gases. Greenhouse gases are essential for making the planet inhabitable, but excess of them is what causes global warming. Thank you. See you in the next one.